You know, when you think of an asteroid, you probably picture this giant, scary rock hurtling through space, right? But what if I told you they're less like cosmic bullets and more like cosmic gas stations? Seriously, ancient floating resource depots that could literally unlock humanity's future in the stars. Okay, let's get into it.
This really the ultimate question, isn't it? We all have these grand visions of bases on Mars, missions to the outer planets, but there's this one fundamental problem that keeps us, tethered to our homeworld.
And that problem? It's all about weight. It's something called the tyranny of the rocket equation, and it is a brutal reality of spaceflight. For every little bit of food, water, equipment, and especially fuel that you want to send into deep space, you need even more fuel just to lift it out of Earth's gravity. It's just an incredibly expensive and inefficient way to pack for a long trip.
But what if we didn't have to pack everything? I mean, what if the rest of the solar system was our own personal hardware store and gas station? This is exactly where asteroids come into the picture, not as threats, but as these amazing opportunities just waiting for us, right in our cosmic backyard.
So what are these things really? Well, an asteroid is basically a primordial building block of our solar system that just never quite got around to becoming a full-blown planet. They're like little time capsules, floating museums holding the raw ingredients of our cosmic neighborhood from billions of years ago.
Now, when it comes to actually getting to them, not all asteroids are created equal. The ones we're most interested in are called near-Earth objects, or NEOs for short. These are the ones whose orbits bring them tantalizingly close to us, which makes them the low-hanging fruit of the solar system.
And check this out. This shows you exactly why those NEOs are so important. Over on the left, you've got the millions of asteroids out in the main belt, way out between Mars and Jupiter. Getting there costs a ton of energy. But on the right, those are the thousands of near-Earth asteroids. They are absolutely our prime targets because reaching them is just so much easier and cheaper in terms of fuel.
Okay, so we found our conveniently located stores. The question now is, what's actually on the shelves? What can we get from these floating rocks? Let's go take a look at the inventory. So it turns out asteroids basically come in three main flavors. You've got your C-types, which are rich in carbon, and, this is crucial, water-bearing minerals. Then you have S-types, which are stony and full of silicates for building things. And finally, M-types, which are pretty much just flying chunks of pure metal, like iron and nickel. Each one offers a different, totally vital resource.
Now, what's so wild about this is the breakdown. The most common type of asteroid out there, the C-type, just so happens to contain the single most valuable resource for exploring space, water. And that isn't just a lucky coincidence. That's an absolute game changer. So let's zoom in on these C-types. Think of them as giant, dark sponges that soaked up water billions of years ago, locking it away inside their minerals. Tapping into these cosmic reservoirs is really the first, most critical step to being able to live and work in space long-term.
Then you've got the S-types. These are your construction supply depots. The silicates they're made of are the raw materials for making things like concrete, glass, even bricks. So instead of launching super heavy building materials from Earth, we could just build our habitats with materials already waiting for us up there. And finally, the M-types. Oh man, these are incredible. They're thought to be the exposed metal cores of ancient little planets that got smashed apart a long, long time ago. They offer pure, high-grade metals, perfect for building structures, tools, you name it. They are literally flying mines. So, we've got our cosmic hardware store all inventoried. We've got water, building materials, and metals. Awesome! But how do we actually turn these raw ingredients into the fuel, the parts, and the oxygen that we need to survive in space? Well, let's see how you turn a rock into a rocket ship.
The power of water in space is almost magical. I'm not kidding. First, and this is the big one, you can split it into hydrogen and oxygen, the most potent chemical rocket fuel we have. It also gives you breathable air and drinking water for your crew. And a layer of water is an excellent shield against dangerous space radiation. It is the ultimate multi-tool.
And believe it or not, the process for making this fuel is surprisingly straightforward. You just scoop up the rock, you heat it up to bake out the water as vapor, you collect that vapor and condense it back into a liquid. And then you use solar panels to run a current through it, that's electrolysis, to split it into hydrogen and oxygen. A self-sustaining gas station, powered by the sun. Pretty cool, right?
And the other materials are just as valuable. With all that metal, you can use 3D printers to just manufacture spare parts or tools whenever you need them,
which is a huge deal on a long mission. With the silicates, you can build permanent infrastructure, you can even bake the oxygen right out of the rock itself. The point is, this lets us truly live off the land.
Now, this all sounds pretty fantastic, maybe a little science fiction, but it's not. We've actually already started taking the first steps on this journey. Of course, just like with any grand adventure, there are some really serious hurdles we still need to figure out.
And this isn't just some theory. I mean, look at the progress we've already made. We first landed on an asteroid way back in 2001. Then Japan's Hayabusa mission proved we could bring a sample back home. The Dawn mission confirmed water was there for the taking, and just recently, NASA's OSIRIS-REx brought back a massive sample from Bennu, a perfect C-type target. We are actively learning how to do this right now.
See, these missions weren't just about pure science. They were absolutely crucial engineering demonstrations. They taught us how to navigate to these tiny little low-gravity worlds and actually interact with them. They proved we could sample them, even get at stuff below the surface. All of these are foundational skills you have to have before you can even think about mining.
But yeah, it's not easy. I mean, think about it. How do you dig into a rock when there's basically no gravity to hold your shovel down? You might just push yourself away. Engineers are working on all kinds of creative solutions, from harpoon anchors to magnetic rakes. Then there's the challenge of generating enough power for all this and managing all the fine, abrasive dust that can just wreck your machinery. These are the really tough problems we're trying to solve right now.
Which, brings us right back to the big picture. Unlocking the resources in these ancient rocks could finally, fundamentally, break that tyranny of the rocket equation. So the real question isn't if we'll need these resources, but how quickly we can master them. Because the moment we do, the solar system stops being this vast, empty ocean, and it starts to look a lot more like a coastline, dotted with harbors, just waiting for us to explore.